All right, so the next question we're going to answer is, well, how do I know if the function is invertible? How do I know if there is an inverse function? And we'll come back to that answer, but let's start by graphing this function. So if I graph my function, again, I've got a parabola that's been shifted right 1 and down 3. Okay. Graph this. And we'd say, well, is this a function? How do I know this is a function? Well, it passes the vertical line test, so it definitely is a function. Okay, it has a domain. X is an element of all real numbers, but y is limited. Y, the lowest y value we have is -3. So we would have from -3 to infinity. That's our domain and range. Well, now let's find the inverse. Okay, so if I find the inverse, and I'm kind of skipping ahead here, remember, how do we find an inverse? Switch x and y, solve for y. So I have x is y minus 1 squared minus 3. Okay, so solve. Add 3 to both sides, and then square root both sides. Hopefully in your head, when I say square root both sides, you are already hearing, well, that gives us a plus or minus answer. So I have plus or minus root x plus 3 equals y minus 1. Okay, so I add 1 to both sides, and I have 1 plus or minus root x plus 3 equals y. And we're done. Well, the problem with that is if I plug in a specific x value, so I plug in, let's say 1. If I plug in 1, then my answer would be 1 plus or minus the square root of 1 plus 3. Okay, so I'm plugging in a single x value, and I get 1 plus or minus 2. I get 3 or -1. So I plugged in a single x value, and it gives me 2 y values. And if you remember a definition of a function, that's not okay. You cannot do that. And what that would look like, it would look like, again, a square root function that's been shifted left 3 and up 1. Oops, I go up 1. Well, and we look at that and we say, well, that's not a function. Okay, this is not a function, and we know that from our definition, and then because it doesn't pass the vertical line test. So now I come back and I say, well, let's go back to the beginning and say, well, how do I know if that original function was invertible? Well, we are going to add to our list of tests, we are going to add the horizontal line test. So I know this blue function, I know that's a function because it passes the vertical line test, but it is not invertible because it doesn't pass the horizontal line test. I can draw a horizontal line and it crosses in more than one point, so it's not invertible. And you say, well, good, we're done. Unfortunately, no. What we do then is we limit the domain to make it invertible. So I'm going to say, I'm going to change this domain. Instead of x being all real numbers, I'm going to get rid of part of it. And specifically, I'm going to get rid of half of it. Well, now this function passes both the vertical line test and the horizontal line test. And so our new domain is x is an element of, and our lowest x is 1, and we go up to infinity. Okay, so what does that do to our domain and range of our inverse? Well, these are going to swap. Okay, so my new domain is from -3 to infinity, and my new range is from 1 to infinity. Okay, and so we come back down here, and when we have that plus or minus, we are just going to stick with the positive. Okay, so that it is a function. So again, I'm going to change that so I have just plus. And so my inverse function, h inverse of x, is 1 plus root x plus 3. And I'm sorry, this is on a page change for you. Nice and easy on my tablet, but not for you. So if I graph that, my square root function has been shifted left 3 and up 1, and I just have this part this time. And now we can see, now we have that symmetry across the line y equals x. Okay, go ahead and try number 4 and then come back to the video.